Hi, and welcome back. I'm Hank Preston, a developer evangelist with Cisco DevNet, and today I'd like to talk to you about Python at the Edge, supercharged network event management. This lesson is part of our network programmability video basics course and is in the application hosting in the network module. In this module, we've already talked about why you might want to host applications in the network, and then the ability to actually have Linux at the edge in our network devices. Now we're going to talk about how we can use that guest shell environment to run our Python scripts. If you want to code and follow along with me, I highly encourage it. Go on up to GitHub, github.com/ciscodevnet netprog_basics. You can clone down all of the lab exercises and sample code that we're running in all of the video modules. Each lab includes a README that will walk you through the prerequisites to set up your own workstation so that you can follow along, as well as information on how to access the DevNet sandboxes that you need for these exercises. In this lesson, we'll be covering Python prerequisites, the guest shell bits. Now, the previous lesson to this one, we actually talked about guest shell in depth, how to enable it, how to manage it, how to install applications and modules within guest shell. So if you haven't watched that lesson yet, I encourage checking that one out before continuing in this one. But we will review the basics before we get started. Then we'll talk about how we can explore the different capabilities that Python on guest shell offer us as we go through, and then we'll end with a discussion about my favorite feature of Python, which is where we can tie that with embedded event management, that programmability utility that we've had in Cisco devices for quite a while now. So the Python prerequisite is we do need guest shell. And as a reminder about what guest shell is it's a 64-bit Linux environment running directly on our iOS and NXOS platforms. This gives us a containerized version, typically of CentOS, where we can actually manage that just like we would any Linux environment. We can use it to install, update, and operate third-party applications like agents from Puppet, Chef, or Splunk. But what's key for our lesson today is that it's bundled with Python. It lets us run scripts directly on our boxes. Now the guest shell we have a couple of different flavors of guest shell depending on your platform and the software version you're on. Now guest shell was originally launched in our NXOS platforms, and we call that guest shell 2.1. And if you have NXOS version 7 or higher on your Nexus 3Ks or 9Ks, you have access to guest shell today. Now recently added to the iOS XE platform in 16.5, we have guest shell 1.0. Now, depending on the hardware platform you have, you'll be offered either the light version of guest shell or the full-featured version. And that just is based on the amount of CPU, memory, and storage space available. Now, looking at the chart here, we can see that we do have a few differences across the area. In general, basic Python scripts written in Python 2 will work similarly across the entire portfolio. But depending on if you start to use different Python libraries and modules, or if you want to start moving to Python 3, it is important to recognize and refer back to this chart and the other information in the documentation about some of the specific differences between the platforms. Now, why Python for network programming and network programmability? Well, Python has become the de facto automation language for today. It is an easy to learn, but also very powerful programming language that we can use to overcome some of the shortcomings that when we're working with raw CLI. Python gives us robust looping capabilities, conditional capabilities, and then by embedding Python into the network, we can actually provide programmatic access to all of the device configuration and operational data right on box. Now for this exercises and what we're going to go through, we do have a bit of setup that we've already done inside of guest shell. We've enabled it and configured it for proper DNS. We've installed Git inside of that Linux environment and cloned down the entire code repo for the network programmability video course. Now, if you've gone through the previous lesson for this on guest shell, you've seen all the details on how to do that already. Let's explore Python within guest shell and some of the capabilities that it offers us. First of all, let's talk about on-box versus off-box Python, because you're probably going to use both and may have more experience today with off-box Python. Now, when we refer to on-box, this is when we're actually executing the scripts locally on our switcher router. And these are ideal for use cases where running that code at the edge directly on the host device makes a ton of sense. For example, provisioning use cases. If during your activities in day zero provisioning using ZTP, zero touch provisioning, or power on auto provisioning, POAP, on the Nexus switches, we can actually use on-box Python to run Python scripts during that provisioning process. Now, one of the use cases we'll talk about today is automating the event responses. What do we want to do if an event is detected at the edge? Well, it can be handy to run and distribute the actual operations of the actions to those at the edge devices themselves. So by integrating Python with EEM, we can actually take more programmatic actions to our events detected on the devices. Application development, IoT use cases, these are all great examples when on-box Python makes sense. However, we also have off-box Python. In this case is where we're running our Python code either maybe on our laptops or centrally in a network management system. And we're using different APIs from our Python code to reach into the network. Now, those APIs might be modern network programmability APIs like netconf or restconf, or they could be just CLI interactions using that as an API to configure and manage your device. As we go through these are ideal use cases when you're trying to do robust configuration management across an entire network, or trying to gather and process operational data and telemetry information. Or for centralized network controllers, we can also use off-box Python to interact with the devices. In both cases, we're still using Python. It's the exact same programming language, the exact same skill sets we'll see in both on-box and off-box. Now, when we talk about on-box Python features with iOS XE or NXOS, we have several things that are offered to us. We get an interactive Python prompt, which means we can actually run Python directly on the box and then type Python commands one line at a time, like you've probably done on your laptop when learning how to use Python in general. We can also write Python scripts and copy them up to our box using utilities like Git or just basic copy utilities like TFTP or SCP or HTTP protocols. And once those Python scripts are on the devices, we can run them directly on those boxes. Now, we do include a Cisco Python API library, so a Python library along with Guest Shell, and that Python library gives you the ability to interact with the host device, grab configuration information or operational details, or make configuration changes using a Python library to simplify that process a bit. And we'll see examples and more details on that library shortly. As I mentioned on the last slide, we can also integrate Python capabilities with zero-touch provisioning and embedded event manager, other features that are part of the network programmability feature set inside of the Cisco platform. If we look at each one of these, we'll start with interactive Python. Now, at the enable prompt on your device, so either at your iOS enable prompt or your NXOS enable prompt, you can simply run guest shell run Python. And that syntax says, inside of the guest shell, please run the command Python. And that will then generate an interactive Python prompt right on the box that you can then run Python commands. So in this example, we can see we're running just the basic hello world Python. X equals hello world, print X, hello world, and there we go. Now, moving on from there, we can get into actually running Python scripts on our boxes. So in this case, we can see that we're actually at that enable prompt again, using guest shell run Python, and then passing in the script name and any arguments it may need for that script to process. So now we've converted our hello world commands into a basic Python script and then running that directly through. As we go through, you may want to add additional Python libraries into your environment. A common one you may want to access is the request library, which makes it very simple and easy to send REST API commands from Python. Now, request is something you need to install. It's not included by default with Python. And so we use the same behavior, the same procedures we do when managing Python on our laptops or a workstation. We use pip to install requests. In this case, we sudo pip install request so that we can get elevated privileges inside of Linux. Then we have access to that request library to go through and use it. Now, as I mentioned, we do include a Cisco Python API library that provides a set of different commands and functions that you can use to interact with the CLI on the underlying host device. So as you're writing your Python scripts or working interactively, we can send CLI commands using cli.cli to send those commands out. And there are variations for that, whether you want to return your data back as a JSON output or just print it to the screen. We also have cli.configure and configure-p to send specific configuration commands in a way that doesn't require us to previously access the config mode as we would with the CLI options. Now, as you'll note in here, I've got a couple of asterisks on the screen. Now CLI.CLID, where we actually get the data back in a JSON format, that is NXOS only, and the configure commands are iOS XE only. So there is a bit of variation between the platforms, so be sure to read the specific documentation about the platforms you're using. Now we are working hard at Cisco to bring these things, bring the different implementations together for some consistency, but there is some differences to be aware of as you dive in. Let's take a look at how we might use the Python APIs here. To get started, the first thing we need to do is import those libraries, just like we would with any Python library that we're working with, whether it's requests or regular expressions. In this case, we import CLI. Once we have that, we then have access to those CLI functions that were there. In this first one, we can see we're using CLI.CLI and then just sending off the command we're after. In this case, show IP interface brief. Now, some of the CLI does have different variations for options. In this case, what the CLI.CLI gives us back is it returns a string of the output from that command. And so we can see that here, that inside of the string, we can see that the new line characters exist where it would actually roll to different areas. Now, this is useful if you want to save the output of this command for further processing. If you simply want to print that output to the screen and you're not worried about saving it to process it further, that's where CLI.CLIP comes in. If we run this same command using this function, we can now see that rather than returning a string, it actually prints it out on the screen in the same format we'd be used to if we ran this directly on the device itself. In this case, this is a great way to build Python scripts that may gather up a bunch of different details and output it to the screen and provide kind of your own version of a show tech as an example. Moving on to some of the configuration ones here, we can see that we've got CLI.configureP. The configureP command, rather than taking a single command structure, it actually takes a list object with all of the commands that you want to run. So in here we can see that we have 3 items in our list. We start with interface loop 100, so a new interface command, creating a new interface. The second command sets a description, and then the final command that rolls over onto the next line on the screen here sets an IP address on that interface. What's nice about the configureP command is it actually prints out and shows us the status per line, and we can see that line 1, 2, and 3 were all successful. We can then go back and we can leverage our CLI.P function, or CLI.CLIP, and this gives us the ability to actually show run interface loopback 100 and verify that indeed we were able to create and configure this interface using the Python library that's through there. One of the other capabilities that we have with Python is the ability to interact with our day zero provisioning strategies. In this case, using day zero provisioning, when we talk about that into iOS XE or XR, that's zero touch provisioning or ZTP. And in NXOS, that's the POAP protocol that goes through. In each of these cases, the process is about the same. When a network device boots up and lacks a startup configuration, it goes out to a DHCP server using options 150 and 67 to determine the location of a TFTP server that contains a Python script that will notify that device on how to become provisioned initially. It then downloads that Python script from its TFTP server and runs the information. Now that script will have basic copy details on how to bring down the proper image, so the version of iOS XE or the version of NXOS that's desired, as well as the configuration file to initially install. By leveraging Python, as opposed to just some basic other styles of scripting and commands, we get a much more robust capability around our day zero strategies. Enough of the slides for a bit. Let's take a demo and see how these features actually work on a live device. All right, to get started for this demonstration, we'll go ahead and we'll log into our iOS XE device. Now that we've logged in, we'll enter the Python interpreter using guest shell run Python. We can see that we've loaded up and we're working with Python 2.7. Now let's explore some of those Python CLI APIs we were looking at. So we'll import CLI. Now with CLI imported, we'll walk through the ones that we've talked about in there, starting with the CLI.CLI. So CLI.CLI, and then we'll run show IP, got to type it correctly, show IP interface brief. When we run this, we see we get back a string object that we can use. Now I just ran the command, but if we actually go through, I can see that I can store that, and I can store that in a variable called output. And with that in place, now I could actually manipulate that output. So I could do print output, and this will then go ahead and print the information. But now I've saved the output of that CLI command. If all I wanted to do was print it, then I could use the CLI.CLIP, and that's the equivalent of saving the string, printing it, and then deleting the variable for it. So show IP interface brief. And so now I printed it out. Now if I want to make configuration, we use the configuration option that goes through. So we'll say CLI.configure. We'll use P so that we can print the output as we need it. Now as I mentioned, this takes a list object. So we're going to say the first one will be interface loopback 100. Our second command will be to set a description on, or our second element in the list will be to set a description. So description equals configured by Python. And then finally, we'll give it an IP address. IP address 192.168.0.100, 255.255.255.0. And then we'll close our list off and then finish our function. We send that off and we can see that we've got 3 lines of success, just like we saw on the slide. So I'm doing well so far. And we'll verify that the configuration was correct with CLI.CLIP. And then we'll say show run interface loopback 100. And we can see indeed I have configured and set up my loopback. Now using this combination of CLI libraries as well as the full power of Python for conditionals and looping and regular expressions, you can see the power that's available by running these scripts directly on Box. Now we're going to move on and actually see a great use case of using Python on Box with embedded event management. Now if you're not familiar with embedded event management, it's a utility and a function that's been available inside of the Cisco platforms for years. It's a way to automatically have your device monitor for specific events. Those events might be a syslog entry, a trigger and a counter being fired, specific time regularity, so every day or every hour you want to take certain actions. Now traditionally embedded event management, you would fire off basic CLI commands, or maybe you'd have it run a tickle script, a TCL script to go through. With Python on Box, we can now actually have the EEM event trigger an action which is running a Python script, which gives us all the power of Python for our programmability, and now we can tie that directly in with the actions on Box. So in here, what we're going to do is we've created a Python script that will take our desired action. In this case, we simply want a no shut-in interface as it goes through, but our script could be far more sophisticated from this to logging information, verifying configuration details. Kind of the sky is the limit with what you want to do in your Python script. For this demonstration, a very basic one, we want a no shut-in interface. What we do from there is set up the embedded event manager applet. Let's dive in and kind of see how this differs from what we would typically see. The difference we're going to find is actually in the action, and what we'll see is we're actually running guest shell run Python and then tying it to a script that has the action that we're after. In this case, it's our interface up script we just looked at. The rest of the structure of the applet is just how we've done before. We start out by creating the new applet and giving it a name, in this case interface loopback 100 shutdown. The idea behind this demonstration is you've got particular interfaces in your environment that should never be shut down. And should they mistakenly be shut down for some reason, we don't want that to cause an outage or an extended outage. It would be great if the device itself could recognize that behavior had happened and then recover automatically. Now what we're looking for in here, what the event is that we're after, is the syslog pattern that shows us that an interface was shut down. So interface loopback 100, change state to administratively down. Now should that event happen, then we get into our action statements. The first action statement moves us into the enable mode, and then the second action statement is the one we looked at to start with, which is where we actually run our Python command using guest shell through there. By running through those, once we've set up our embedded event manager applet, now let's go ahead and test it to trigger it out to make sure it's working as we want. Now a couple of pieces here, just like we would debug anything else, we'll turn on terminal monitor, and then to watch the actions of embedded event manager, we can debug event manager action CLI, which will show us the status of what's going on. We can then go through and forcibly shut down our interface, which is the action we're looking for. We can see that here. Now once we make that configuration change and we shut down that interface, the debug commands will show us what happened. And inside here we can see that it's processing exactly as we expected. It shows here that we are sending out the enable command in this in statement, and then this statement here that wraps around is where we can see that we're actually running that Python script. Now using these debugs are very handy because it can actually help us see the output of our scripts as we're initially setting them up. And so in here we can see all of the output that went through, and we can see the success messages for each of the configuration lines that went through to no shut it. Very handy for testing these out. Now we don't just want to see these in slides, of course. Let's take a look at how this embedded event manager with Python looks in real life in a live demo. So I've already gone ahead and configured the EEM applet, so let's take a look at that. Show run section event. So in here we can see that same applet configuration we looked at. Our pattern we're looking for is interface 100, loopback 100 going down. Then we will go ahead and run our guest shell, run using guest shell, our Python script that will bring that interface back up. Now with that ready to go, let's go ahead and turn on Termon so that we can actually watch what's going on, and the debug for event manager action CLI, and this will let us watch what's going through. With that ready to go, we'll do config T and then interface loopback 100, and we will shut it down, simulating that mistake happening potentially by an engineer on an operations team or something like that, turning off the wrong interface. And there we go. So we've seen it, we saw it, and it happened really quick, so let's look at what we see. Here we can see that we see our line protocol going down. We see it changing to administratively down, which is the syslog message we're actually looking for. This kicks off the EEM to start, and we can see the different commands. It starts out with the device EEM opening up a connection, moving into enable mode, and then it runs our guest shell command here, where we're running guest shell, run Python, and our script passing in loopback 100 is the interface to bring back online. Our two configuration lines go through successfully, and then we can now see our syslog message coming back, where we can actually see that interface loopback 100 changed its state to back up. Very quickly this processed and went through so that we can see how we can tie in our Python scripts with our EEM for processing. All right, let's summarize what we've gone through so far. We started out with reviewing the guest shell environment available within iOS XE and NXOS devices and how we can use it for Python execution. We explored some of the different use cases and methods for running Python on box, and then ended with a description and an example of how we can use Python scripts and embedded event manager for more powerful event processing and automation in our network. As always, I encourage you to complete the entire Network Programmability Basics course. Run all of the exercises, connect to our sandbox, grab our sample code, run through the exercises just like you saw me do in this video. And then join DevNet for all of the learning labs and other development sandboxes available. If you do have questions, feel free to come find me. You can reach me via email or Cisco Spark at hapresto@cisco.com, or up on Twitter at hfpreston or GitHub at hpreston. And Cisco DevNet's available on Twitter, Facebook, and GitHub as well. Thanks so much for joining me for this lesson. I look forward to seeing you for the next one.